Good morning, sir. I'm Vinay Kumar Reddy. Present, I'm pursuing my BTech in Annamachala Institute of Technology and Sciences, Rajampet, in the stream of Electronics and Communication Engineering. Today, we are here to give paper presentation on retinal boundary segmentation in OCT images using active counter model. These are the contents in this paper presentation: abstract, introduction, objectives, existing method, proposal method, block diagram, methodologies, advantages, conclusion, and references. Coming to the abstract, optical coherence tomography imaging is a precise and significant approach in retinal diagnostics at the layer level. There are many layers of OCT under the macular area of the eye are to be highlighted in this work. The proposed counter model is used to determine the nerve fiber layer, ganglion cell layer, inner flexiform layer, inner nuclear layer, outer flexiform layer, outer nuclear layer, inner segment, outer segment, and retinal pigment epithelium. In pre-processing approaches, the medium filter and histogram equalization are utilized, and the canny edge detector coupled with watershed thresholding provides post-processing so that the layers can be easily identified. Coming to introduction part, around 39 million people worldwide are blind and another 217 million have moderate to severe visual impairments. Nearly 80% of all vision problems can be prevented or cured if the condition is detected early and treated promptly. Optical coherence tomography can capture 3D cross-sectional images of human tissue at micron resolutions, and it has been widely used in a number of medical and industrial imaging applications. Coming to objectives, the main objective of this project by using different methods are used as pre-processing methods and canny edge detector along with watershed thresholding provides the post-processing such that layers can be easily identified. It provides accurate segmentation of retinal layers. Coming to existing method, as a reference we have taken existing methods like graph based technique and dual gradient based technique. In graph based technique they have identified only 7 retinal layers, whereas in dual gradient based technique they have identified 9 intraretinal boundaries, but the results are not accurate and also it is difficult to identify the layers. Coming to proposed methods, we are using medium filter and histogram equalization methods. The medium filter is a nonlinear filtering method. It is used to remove the noise during capturing of the input image, where histogram equalization is used to increase the contrast of the input OCT image.
This is the block diagram of retinal boundary segmentation in OCT image. This block diagram can be divided into three parts: pre-processing, post-processing, and layers identification. Median filter and histogram is the pre-processing method. Global image threshold using Orchus, canny edge detector, morphological image processing are the post-processing methods. Polynomial curve fitting, polynomial evolution, generation of linearly spaced vector, cubic spline data interpolation. These are the layers identification process. The input image is given in the form of OCT. Medical image scan of retinal part of the eye are acquired by the corresponding medical imaging modality. As the input image contains distortion and error occurred during the image acquisition process has to be removed. In this regard, the input image is subjected to pre-processing using median filter and histogram equalization. The median filter is considered as a non-linear filtering process in image processing algorithm. It tends to remove the certain amount of noise induced during the capturing of the image. Further, the resulted image is fed to histogram equalization, where the enhancement of the image is carried out based on the uniform distribution of pixels towards the gray shades of the image. During this process, an histogram plot comes into an action which indicates the relationship between number of pixels and corresponding intensity value. Thus, enhanced contrast of the input image is obtained. The enhanced image is subjected to global image thresholding by means of Orchard's method. Here, global threshold level of the image is considered to convert intensity image to a binary form of the image. Once we obtain the image with only black and white pixels, it has to be undergo edge detection process using canny edge detector. The resulted image is subjected to morphological image processing, where the shape-based image processing algorithms are carried out. Here the boundaries are easily marked as each intensity value have their own regional boundaries based on intensity values. Later, the output obtained from the morphological operation is subjected to polynomial curve fitting such that the coefficients of polynomial are identified for the boundaries. The generation of linearly spaced vectors are drawn out for those polynomials as these vectors provide direct control over number of boundaries involved and always includes the find endpoint. These vectors are interpolated by means of cubic spline data interpolation for the corresponding boundary point and returned a piecewise polynomial structure having find layers divided by the colored lines. Thus, the boundaries of the layers such as null fiber layer, ganglion cell layer, inner flexiform layer, inner nuclear layer, outer flexiform layer, outer nuclear layer, inner segment, outer segment, retinal pigment epithelium are highlighted under the macula part of eye in the OCT image. Next, coming to methodologies. This figure represents the OCT input image with noise which is generated during capturing of the medical image. In pre-processing, the figure represents the by using median filter we have to remove the noise which is generated in the input image and adjusting the contrast of the image by using histogram equalization. In post-processing, the figure represents the enhanced image is subjected to global image threshold by means of Orchard's method. Here, global threshold level of the image is considered to convert an intensity image to a binary form of the image. In this figure, by using canny edge detector, the boundaries are easily marked as each intensity value have their own relational boundaries based on intensity values. This figure represents the final output of the input OCT image that we have identified 9 intra-retinal boundaries and the layers divided in the colored lines such as vitreous, NFL, GCL, INL, OPL, ONL, OS, RPE that are highlighted under the macro part of the eye in the OCT image. Next, coming to advantages, it improves the quality of the image or pixel and proposed system is more reliable and follows simple algorithms. It can easily identify the layers names. Finally, we concluded that during pre-processing, the original image was filtered using a median filter and histogram equalization process was performed. In the post-processing step, the picture from the previous portion is threshold using Orchard's approach and binarized before being subjected to morphological operations to comprehend the boundaries. This is how the active contour approach aids in getting the critical layers of an OCT picture for vivid detection in OCT images. And also it is used to detect which layer has been affected. We have referred from this references.
Thank you.